We are continuing looking at solving linear inequalities in this video, and in this video we're going to look at some more complicated examples where we wind up dividing by negative numbers and it creates an interesting situation for us. When we're solving linear inequalities, we are going to continue to use the same 4 steps that we used with equations, but we do have one small exception. If we ever multiply, or in most cases in these examples, when we divide by a negative number, the inequality sign ends up flipping. So I have 4 different inequalities written down here comparing negative 2x with 4, and I'm just showing 4 of these just to show the different kinds of inequalities. So I've got a less than symbol, I have a less than or equal to, I have a greater than, and I have a greater than or equal to. And the only reason that I'm showing this is I want to show that in both, or I guess in all of these cases, when we try to isolate the x by dividing both sides by a -2, what happens every time we divide by a negative is those inequalities will flip around. So where I had negative 2x is less than 4, as soon as I divide that -2 off, the less than turns into a greater than. A less than or equal would turn into a greater than or equal. A greater than would turn into a less than, and a greater than or equal would turn into a less than or equal. So whatever direction the arrow of your inequality is pointing, as soon as you multiply or divide by a negative sign, it's going to point in the opposite direction. So let's see what that looks like in some examples here. For this first example, we don't have a whole lot going on. There's no distribution to do. I see no parentheses. I cannot simplify because there are no like terms, so I'm going to begin by relocating. And again, when I relocate for an inequality or an equation, I want to keep my letters on the left and my numbers on the right. And in this example, my letter is already on the left side, so I'm just going to take that 16 on the left and move him over to the right. The 16 currently is a positive 16, so I'm going to detach him from the left side using subtraction, which again is fair game as long as I do the same thing to the other side. And so now on the left side, all that's left there is the negative x, my less than symbol is still there, and then 9 minus 16, we wind up with a -7. So now this has not completely isolated the x. I still see a symbol attached to that x. In fact, when you see a negative in front, you can really think of it as a -1 multiplied onto that x. I need to isolate the x. I need anything attached to it to be detached and moved away. And so what I will do is I will divide that negative x by a -1. And as long as I do that to the other side, that's fine, but this is where we need to be careful. I'm dividing by a negative sign, and every time I do that, dividing by a negative will change the sign of the number, which will change the inequality symbol to match. So on the left, my negative x divided by -1 is just x. On the right, my -7 divided by -1 is just 7, but now instead of a less than symbol, because I divided by negative, I have to switch that to a greater than symbol. And so now if I look at a number line, thinking of 0 in the middle, 7 is somewhere over here on the right. In this statement, I cannot equal 7, but I can be greater than 7. And as we saw in the last video, notice that the direction that your inequality is pointing is the same direction that your arrow would be pointing. And if you cannot equal a number, then you are going to use round parentheses to say that you get really close, you just don't quite get there. So I'm not going to equal 7, but I'll be close. And so now if I wanted to write this in interval notation, again, this is a way of writing down infinitely many different values from here to there, from the left to the right. And according to my picture, I go as far left as 7, and I don't equal 7. And I go all the way to the right to infinity. And again, since infinity is not a number, I won't equal it. So when you have no equal sign on your inequality, you will end up with parentheses because you cannot equal it. So again, infinity cannot be equal to, so we use parentheses. So again, the big new thing here is that when we divide by a negative sign, our inequality switches. So let's try another one, same idea. First thing we do is we distribute. Again, the idea here with distributing is to release everything from the parentheses so that they're free to move around. So 5 times 2x gives me 10x. 5 times negative 3 gives me negative 15. And I see no other parentheses, so I'm just going to copy everything else. And now my job is to simplify or just clean things up a bit. And on the left side, I see a 10x and a negative 7x, and those are like terms. So I can go ahead and combine them. 10x minus 7x would give me 3x. Hello. And then the minus 15 won't combine with anything on the left. And then on the right side, I have no like terms, so I'll just copy. So I've distributed, I have cleaned things up, and now I need to relocate. And I'm going to relocate my letters to the left and my numbers to the right. So my 3x is fine on the left where he is, but my 5x on the right needs to move. Currently 5x is positive, so I will detach it with subtraction, which is fair as long as I do the same thing on the other side, again, to maintain the balance. And so 3x minus 5x gives me negative 2x. And then, oh, I guess at the same time, let's multitask here. Let's move our numbers to the right. So where I have a negative 15 on the left, let's detach that with addition and do the same on the other side. All right, so again, we added 3x minus 5x. We got negative 2x. The 15s cancel. The 5x's cancel. Oh, multitasking is great. All right, so now I have my greater than or equal to, and then 9 plus 15, that'll give us, oh dear, that'll give us a 20, oh, come on. That'll give us a 24 here. And so I've got all my letters on the left. I got my number on the right. Now my job is to isolate the variable. I need to get x by itself. Right now there's a negative 2 attached with multiplication, so I will detach that with division and do it on the same thing on the other side. But notice this is again a step where I'm dividing by a negative, and that's where I have to be extra careful. So negative 2x divided by negative 2 is x. 24 divided by negative 2 is negative 12. But because I divided by a negative, that greater than or equal to symbol changes to a less than or equal to. So the arrow is pointing in a different direction. So let's see what this will look like on a number line. Negative 12 will be somewhere over here on the left. According to my inequality, I can equal negative 12. So here's me equaling negative 12. And I can be anything less than or equal to. So less than will go left. Again, something to notice is that the direction that the inequality looks like it's pointing is the same direction that your arrow will point. And when you see the equal to, that tells you that you can equal that number, which we often use a square bracket to notate. And so if I was looking at my interval notation, again, that notation that allows me to write infinitely many answers from here to there, from the left to the right, the farthest left I go with that arrow says all the way down to negative infinity, but I'll never equal it because it's not a number. And I can go all the way to the right up as far as negative 12, which I can equal, so I'll use square brackets. So any numbers between negative and infinity all the way up to negative 12, anything in between, we can include in our solution. It'll make the statement true. And let's look at one last example here. Again, following our same 4 steps, but being extra careful at the end if we divide by a negative. So first step is I distribute. Again, this step is to remove the parentheses to try and loosen up all the terms, free them up so that they can move around. So I've got 3 times 3x, that's a 9x. I've got 3 times 5, which is 15, less than or equal. 7 times 2x is 14x. 7 times negative 1 is negative 7. And then I have that plus 2. So that's the distribution. Now I need to clean things up a bit. I'm going to simplify. And on the left, I have no like terms at all, but on the right, I see a negative 7 and a 2 that can join up. So on the left, let's leave it alone. Nothing to do there. On the right, we have the 14x, and then negative 7 plus 2 will give us a negative 5 combined. So we've distributed and we've cleaned things up, and now the job is to relocate letters to the left, numbers to the right. So I will leave the 9x on the left, but this positive 14x needs to be detached with subtraction to move over to the left side. Again, make sure we maintain that balance. At the same time, let's move all the numbers to the right side. So the negative 5 is fine where he is, but this positive 15, let's detach that with subtraction and do the same thing on the other side. That's how we relocate terms. So now on the left, 9x minus 14x, that will give us a negative 5x. We'll notice that the 15s cancel, the 14x's cancel, and so I have less than or equal to negative 5 minus 15 is a negative 20. So far, all I've done is I've loosened up or freed up the terms. I've combined like terms. I've relocated terms. Basically, I'm just moving things around. It's this very last step that we have to be careful of. Not about moving things, but about detaching coefficients. In this particular case, x is not by itself. If I move to isolate him, I need to detach the negative 5 using division. And this is the part that we have to be careful of. Whenever we divide by a negative, we have to switch the inequality. So negative 5x divided by negative 5 is x. Negative 20 divided by negative 5 is 4. But in dividing by that negative number, our less than or equal to inequality now changes to say greater than or equal to. So the direction that the inequality is pointing, that direction changed. It used to be pointing to the left. Now it's pointing to the right. And if I want to look at a picture of this, again, looking at my number line, 4 would be somewhere over here on the right. It's positive. It says that I am greater than or equal to 4. So since I can equal 4, I'll go ahead and make a note of that here. And I can also be greater than it. So I'm going to be moving towards the right. Again, notice that the direction that your arrow is kind of pointing in your inequality, it's the same direction your arrow is pointing in your picture. And if you can equal that number, you can equal it, and we'll dictate that with a, or we'll denote that with a square bracket. And so when I go to write my interval notation, again, that's the notation that says infinitely many different values from here to there, from the left to the right. As far left as I go is 4, which I can equal. I go all the way down to positive infinity, which I never can equal. So again, I can equal 4 based on my inequality statement. I never equal infinity. Those will always have parentheses on them. So again, the big thing to keep in mind with these is that you can work them, for the most part, exactly as you did equations: distribute, simplify, relocate, isolate. The only place you have to be extra careful is in that isolating step. If you ever divide by a negative, you change your inequality symbol around to point the other direction.